So good morning, hello. I'm Neil Roberts. I work on the graphics team at Igalia, and I'm going to talk about VkRunner. So that's an overview of the talk. So what is VkRunner? So as you know, I'm sure, on a modern graphics driver, the biggest part of the driver is basically a compiler. So when developing the driver, the biggest thing you want to test is obviously the compiler. So VkRunner is a tool to help test running shaders on your Vulkan driver. So it's inspired by, there's a tool in Piglit. So Piglit is a test suite for OpenGL. And Piglit has a tool called ShaderRunner, which is basically the same thing. It lets you write little test scripts which just have shaders in them, and a few test commands to run the shaders. So VkRunner is the same idea, but for Vulkan. So it tries to have the minimal overhead to write a test just with a simple script. So that's an example of a complete script. So it has like the Windows INI format with a section for each shader. So in this case, for the vertex shader, I've just said vertex shader pass through. That's just a shortcut to make a minimal vertex shader, which just copies one attribute over to geoposition. And then I've made a little fragment shader, which just outputs green. And then in the last section is the test section. So it's a really high-level language to just run some tests with the shader. So in this case, draw rect, it just draws a full-screen rectangle, and then probe, that probes the frame buffer for the color. And then to run it, so it's just a standalone program. You just run it with the name of the script on the command line, and it tells you whether it worked or not. And in this case, it didn't work because the shader wrote a green color out, and then it's probing for a red color. So it's telling you it got the wrong color. So behind the scenes, so that's VkRunner, because on Vulkan it can't consume GLSL shaders, obviously. So it needs to consume SPIR-V shaders. So VkRunner compiles the GLSL shaders into SPIR-V by invoking GLSL lang as an external process. And it creates pipelines because for all of the state that it's needed to run the commands, and it creates an off-screen frame buffer. So unlike ShaderRunner on Piglit, on ShaderRunner, it uses the Windows system to create an actual like X window or a Wayland window or whatever. On VkRunner, because you don't necessarily need a Windows system for Vulkan, it just uses an off-screen buffer. And then it puts all the test commands into a command buffer and executes them. And then you can probe the result as one of the test commands. So just a bit of history. Why did we start working on this? So Igalia has also been working on adding SPIR-V support to Intel's OpenGL driver. So that's via the ARB-GL SPIR-V extension. So on the Intel i965 driver, the compiler for OpenGL SPIR-V and Vulkan SPIR-V, it's the same compiler. So we were testing the SPIR-V on OpenGL by converting a bunch of, by trying to automatically convert most of the ShaderRunner tests in Piglit to SPIR-V. So we had a script started by Nicolo Hanley, and we continued working on that to convert a huge amount of tests from Piglit into SPIR-V, and I think that ended up testing quite a lot more of the just the general SPIR-V compiler than had been tested with the Kronos CTS test. So it picked up a few more problems that perhaps weren't seen before. So when we ran into a problem on the OpenGL SPIR-V, we often weren't sure whether that's a problem that we'd introduced on the SPIR-V extension or whether that was just an existing problem with the SPIR-V compiler. So we really wanted a quick way to be able to run the shader tests that we had from VkRunner and run them with the Vulkan API as well. So VkRunner was just a way to try and have a utility that works as close as possible to the script format as VkRunner, but obviously just runs on Vulkan. It's not quite exactly the same script format because obviously Vulkan is a different API, so it works slightly differently. So for example, on OpenGL, there's a lot more API to query state about the shaders. So for example, when you compile a shader, you can use the OpenGL API to query what uniforms are available and what the names are. But Vulkan, you're expected to know what you've done, so it doesn't give you any API to tell you what you did. So we can't, for example, use uniform names in the test commands in VkRunner. I have an example. So this is an example with VkRunner using OpenGL. So in the shader, it's got these global uniforms. This is what everyone's used to, I guess. So they're just in some sort of magic global namespace, and the driver is expected to put them somewhere. And they have names. And in the test commands, you can use the actual name you had there to set the value of the uniform. And the VkRunner uses the OpenGL API to get those names out. So with on Vulkan, that's not possible. So to start with, you can't just put uniforms in this magic global namespace. You need to explicitly give a hint to the driver where to put them. So in this case, the simplest way to convert the shader is just to make a push constant block. And so once these are compiled and given to the driver won't let you query the names, as I was saying. So to set the value in the test commands, instead of setting the names there, we set the just using the offsets into the uniform block. And that's also incidentally the same that happens when using SPIR-V on OpenGL. The script that automatically So VkRunner, I don't exactly know the history, but I get the impression it's just sort of started out quite small, as it's sort of grown organically over time, and it's now quite a large single C file. So VkRunner is written from scratch with a bit of hindsight, so I've tried to organize the code a bit more. So like the code to pass the script is separated from the bits that execute it and so on. And also just because writing code for Vulkan, it's a lot more verbose, so obviously you just need to have a lot more code. So keeping it all in one file is not practical. So I've also tried to make it so that a lot of the commands are partially automatically generated. So for example, there's test commands to set all of the properties that are known on a pipeline, and so they're sort of automatically taken from the header file, which describes the pipeline create info. So in VkRunner, there's a command for each member of the pipeline create info struct, and it just sort of automatically puts the value in the right offset in the struct. And the same goes for the formats that it uses, because in Vulkan it has a really nice enum for all of the formats, and they're structured in such a way that just looking at the name of the enum, you can work out exactly how to store data in that format. So there's like a Python script in VkRunner to make a C table out of those enum names, and then so then VkRunner can work with all the formats and like so. If you have your frame buffer in any format, VkRunner can use the C table to work out how to extract RGB values from that to probe the buffer. So some more examples show some more features of what VkRunner can do. So as well as sections for writing the shaders and the test section, and the same as with Shader Runner, there's a section for writing your vertex buffer. So at the start of the section, there's a header to describe the attributes, and so the first part of each attribute is the location, because in Vulkan you have to give an explicit location to each attribute, and then the second part is the format name. So this is slightly different from Shader Runner. In Shader Runner, because the GL format names are a bit strange, it's easier in this case. You can just use the actual format names from the Vulkan enum, and that way it can support all of them. For compatibility, VkRunner can actually understand the Piglit Shader Runner format as well. So yeah, once you've written the header there, you can just write the values out for all your attributes, and VkRunner can use the C table to figure out how to pack them into the struct. So just to make it clear that that's those two attributes there, that sets input for your vertex shader. So in Vulkan you have to specify an explicit location, and that specifies the input for those attributes there. So another section you can add the indices. So if you add the indices section, you can just list your indices as numbers. So then in the test section, just combining those that vertex data with the indices in the test section to actually draw something, then you can just use the draw arrays command. You can say index to use the index buffer, and then you can set the topology using the GL enum. I think it supports the Piglit enums as well to make it easier to convert Piglit Shader Runner scripts. And then in this case, I've just added another command as well. So this is an example of what I was talking about with the automatically generated commands. So the primitive restart enable, that's the name of a member on the pipeline create info struct. So setting that command just sets that member on the pipeline create info struct to true. And then whenever you execute a command, VkRunner works out what pipelines are needed and creates all of the pipelines that are needed, and then picks the right one to execute with that state that you described. And it's got obviously some defaults for all the state. So yeah, try to pick sensible defaults. So most of the time you don't need to set anything. So that script on the left, that's just a combination of those previous examples I showed. And if you run it, it outputs this messed up Begalia logo. As I said, there's no actual WinSys, so there's no actual window when you run VkRunner, but there's an option to output the image if you do want to look at it. So that's how I got that image. So another section, there's a require section. So this is also available in Piglit Shader Runner. So you can just list an extension, for example, and when VkRunner runs the test, it will check that that extension is available on the driver, and if it's not available, then the test will report skipped. So Piglit Shader Runner has already a convention to report either pass, skipped, or fail. So VkRunner copies the same convention. So if the extension isn't available, then it's skipped. But also on Vulkan, as I'm sure you know, you have to, if you want to use an extension, not only do you have to check for it, you have to also enable it. So VkRunner will do that as well. And unlike GL, as well as extensions, Vulkan has features. So even things that are in core, a lot of things are optional. so there's a struct to check for and enable features. So the same thing is here. I just took the struct and converted them all into commands there. So if you list any member of that struct, it will check that the feature is available, and then if so, it will enable it. And you can also set the format of the frame buffer, again using the format enums and the size. It supports all the shader stages, so compute shaders as well, obviously. And so this is just a simple example using an SSBO, and it fills in a table of square roots. So instead of the draw command, you just have a compute command to dispatch the compute. And then obviously it's not writing to the frame buffer, so it's writing to an SSBO, and you can just probe the values in the SBO. So in all the previous examples, all the shader sections were written in GLSL, but if you want to, you can also specify a shader section with SPIR-V source. So this is really useful if you want to test a corner case with SPIR-V, because there are a lot of tests that you might want to test that you can't get the GLSL compiler to generate the SPIR-V that you want. VkRunner has a command line option to, when you run the test, you can make it dump out the SPIR-V disassembly, and then so you can grab that disassembly, copy it back into your shader test, and then you can just modify it as however you want to get the corner case that you wanted to test. So as well as GLSL and SPIR-V shader sections, you can also have a shader section which just literally lists the SPIR-V in binary format. So obviously you don't want to write that by hand, but there is a Python script in the VkRunner repo to batch convert all of your tests to binary. So I guess the main reason you'd want to do that is if you want to run on an embedded platform, for example, where putting GLSL lang is not really practical. So once you run it through the script, the test script looks like that. So the current status, so it can do all the shader stages. It can read and write from SSBOs and read from UBOs. It can do vertex data and simple drawing, and it can probe the frame buffer or SSBOs. It has a library, so when you build it, it builds a little static library with a public header. So that was useful if you want to integrate it into another test suite. It's quite self-explanatory, I hope. You just give it a source file and tell it to execute it, and it will tell you if it worked or not. So far we've got VkRunner has been integrated into the Vulkan CTS suite, the Kronos CTS suite. As far as I know, there's currently only experimental tests. I don't think there's any actual tests relying on it. And that is using the API that I mentioned, so that it can run the tests without forking any external processes. So it's also integrated into Piglit. So Piglit has actual real tests on it now, and it gets picked up by Intel's CI system. So if you write if you implement some Vulkan features and you want to make sure they don't get regressed, the best way I think at the moment is to write, if it's a shader test, then write it as a VkRunner test and just drop it into the Piglit repo. And if you just drop it anywhere under a certain directory, it should get picked up. So hopefully there's a really minimal barrier to adding shader tests for Vulkan. So where am I hoping to go with this? So it's missing quite a few features, probably. The main one, which is quite bad, is missing image and texture support. There's a pull request for this, but I just need to review it and rebase it and make that happen. I've written arrays of buffer bindings because there's an issue open for it, but there's probably a lot of other things missing as well. So on a branch, there's like a user interface. I'm not sure whether it's particularly useful, but mostly just for fun. You can So it's just using GTK. You can write the test script in the editor on the left, and in the background it continuously runs the test and tells you whether it failed or not, and shows you the image as a result. Sometimes in the past when I've been writing GL shader runner tests and it just says fail, and it's quite a pain to keep tweaking all the data to get the image that you were expecting. I was thinking it's quite nice maybe just to have a really tight feedback loop with the user interface. So there's another branch. This is getting more silly. There's a branch for making animations. So this just adds a magic uniform to say the frame number, and then you can run the test multiple times, and it will generate the output into a video via FFmpeg. I just did this because it's kind of fun, but if you know Shader Toy is like a site where you can create lots of demos using WebGL, and it's full of little animations. It's quite easy just to convert those Shader Toy demos to run on VkRunner to make like a sort of crazy offline Shader Toy. But yeah, that's just for fun, really. So there's another project called Amber, which Google are working on. I think they were inspired by VkRunner, so that might be an interesting project to watch too. I will yet to see where it's going to lead. So that's the GitHub repo. It's got the same license as Mesa and Piglet, so take a look. Thanks. Any questions?
Yeah, so I was wondering, kind of related to the video thing, in VkRunner, you can interleave probes with draw calls, and quite a number of tests actually use that.
Yeah.
Does that work there as well?
It does work, yes. There's some caveats because, the question was, can you interleave probe and draw calls like you can in Piglet's shader runner? And the answer, yes, you can, but there's when you do a probe, it flashes the command buffer that it was building up, and then when you start another command, it starts another command buffer. So it mostly works just transparently, but there's some slight. You have to be aware that it's starting a new command buffer, because when you start a new command buffer, Vulkan loses a lot of state. So, for example, if you set some push constants in one command buffer and then you do a probe, you're going to have to set them again when you start drawing again, because it's just going to forget them. Okay.
I saw you said that you will use a Python script to load the data for VkRunner. Are you going to support something like memory mapping for the digital memory access? It's very important feature for those who want to use VkRunner as a domain provided to those customers. Are you going to support such feature like digital memory access or memory mapping for loading buffer? Here.
So the question was
whether you have such plan to support more quickly loading the data from storage into the memory or digital mapping it.
So do you mean the data for the script?
Yeah.
So yeah, if you use the question was, can you load data into the script?
Yes, but would support some feature like GPU directly access those memory in normal memory.
Okay.
Without involved copying to the GPU buffer again.
Okay. So at the moment with the API, you can give it the whole script. That's all you can do. And obviously the buffer, if you had any buffer data, that would be in ASCII, and then it would need to be a conversion process to convert that into memory somewhere. So if you want to give it some data in a memory mapped buffer, it doesn't have support for that, no. But that would be a good...
We can pre-compare some binary data, which will copy from some game, that's it. So you don't need to conversion into the graphic format anymore, and there's no in the embedded device the GPU and the CPU use the same memory, don't have a separate memory.
Yeah.
So it's
So I think if you had a test with it which needed to have a really large input, then yeah, that would be a really good idea. Just to add something to the API so that you can say.
The current API would support it. There is no limit in the API for that.
Okay, so something in the script to say maybe.
I just
yeah.
want to ask whether you have been considered this
Yeah,
kind of thing.
I haven't considered it, but I think that'd be a good idea. Yeah, it's something to add. But I think for the moment, yeah, all the tests that we've encountered so far, they haven't used a lot of input data. So far, it's just everything's contained in the script.
I would suggest either include priority task for the VkRunner.
Okay.
Important factor.
Yeah. Okay. Thank you. Yeah. Thanks.